For our problem, in part A, we need to let ABC be a right triangle with the right angle at A. We need to let hypotenuse BC be the length of 10 inches. If the inscribed circle touches the hypotenuse at a point D, that is, the circle is tangent to the hypotenuse at D, so we need to prove that CD equals 1/2 times 10 plus AC minus AB. So this is the triangle they give us, but we need to break this up to have equal sides. So start in the middle, go there, 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 there. We know that this is going to be 90 degrees, as well as here and there. And then we know that these are going to be equal, because these have the same hypotenuse. These two will be equal. And then right here will be equal. We also know that from C to B is 10. So looking at this, we know that CD equals CE, DB equals FB, and EA equals AF. Looking at this, we know that CD plus DB equals 10. But we also know that BD equals BF. So we can replace that and say that CD plus BF equals 10. But we know that BF is really just AB minus AF. So then we can do CD plus AB minus AF equals 10. But we also know AF equals AE. So for that, we can substitute and do CD plus AB minus AE equals 10. But we also know that AE equals AC minus CE. So we can substitute that in and do CD plus AB times AC minus CE, and all of that equals 10. So we have CE equals CD. So finally, we can say that CD plus AB is AC minus CD. That all equals 10. We need to distribute this negative, which then will give us CD plus AB minus AC plus CD, which all equals 10. So when you simplify all this, you're going to get 2CD plus AB minus AC equals 10. So now we're trying to get CD by itself, so we just subtract over AB and add over AC. So now we're left with 2CD equals 10 minus AB plus C. Okay. So to get CD by itself, we just need to divide over 2. So you have CD equals 10 minus AB plus AC, all divided by 2. But we can just rewrite that as CD equals 1/2 times 10 minus AB plus AC. And then we can write that again to get to look like that. So we have CD equals 1/2 times 10 plus AC minus AB, which is equal to this.
For part B in our problem, it's saying let theta equal 1/2 of angle C, let r be the radius of the inscribed circle, and express r as a function of theta. And it also says use the solution from part A in our answer. So basically the question is asking us to solve for r using theta, or our radius. So we need to find an equation that has both theta and our radius in it. The simplest thing would be to look at side CD and use this triangle because it has our radius right here, as well as the angle we are trying to use right over here. So as we know from our last equation, we know what the CD equals, but now we want to write this as a tangent equation because our tangent of theta is going to equal our r, which is our opposite, and our adjacent being the point CD. And as we know from our last equation, we know CD is equal to 1/2 times 10 plus AC minus AB. So we can simply substitute that in. So tangent of theta is now going to equal R over 1/2 times 10 plus AC minus AB. Now we simply can isolate our R value by multiplying this whole side over to the other side. So we're going to get R equals tangent theta times 10 plus AC minus AB divided by 2, or multiplied by 1/2. Now we could use our trig values to substitute in values for some of these angles, side length. So the first thing we're going to do is we can use the cosine function of our whole triangle to get an answer for AC. We see that cosine of angle C is equal to AC over CB, or tan. And because it's the equation is 1/2 of C, this, instead of being angle C, we could just say cosine of 2 theta is equal to AC over 10. And now we simply solve for AC by moving over the 10, so we get AC is equal to cosine of 2 theta times 10. And now we just do the same thing for our side of AB, but this time we just use the sine formula. So we get sine of 2 theta is equal to AB over 10. And again, we're getting these from this because we want the opposite sine is opposite hypotenuse. That's where the 10 came from. That's where the A and B came from. And the 2 theta is simply our C, angle C. And now we can solve for AB same way we did for AC. So AB is going to give us sine of 2 theta times 10. And now we can plug both of these values into our equation right here, which is going to give us R is equal to tangent of theta times 10 plus 10 times cosine of 2 theta minus sine of 2 theta times 10 divided by 2. Now we can simply take out the 10 from these parentheses and pull them outside our equation. So it's going to look like 10 tangent theta times 10 times 1 plus cosine 2 theta minus sine of 2 theta. All over 2 equals r. And now we can rewrite tangent as sine over cosine, which is gonna make our equation look something like this. We're gonna have sine of theta times 10 times all of this stuff right here over 2 cosine theta. And this again is still equal to r. And now we can use double angle identities to further simplify. So double angle formulas to further simplify this. So we're left with sine theta times 10 and times 1 plus 2 cosine, which is our first identity, 2 cosine theta squared minus 1 minus 2 sine theta cosine theta all over 2 cosine theta still equal to r. And now we see that the ones over here, they cancel out. We can simplify 2 cosine theta on top and bottom to get a 1. So this right here, and this right here, that's a 1. So we're left with sine of theta times 10 is equal to times cosine theta minus sine of theta equal to r. And next we would distribute this into this. So we get 10 sine theta times cosine theta minus 10 sine theta squared is equal to r. And then we can make a double angle with the first part of the identity of 2 sine theta and cosine theta. So this right here would turn into 5 sine 2 theta minus 10 sine squared theta, which is equal to r. And now we have the simplified version of b, which is the final answer is right here.
So for part C, it states that BC remains fixed at 10 inches, yet theta can vary. And it's asking to find the maximum possible value of r. So for what we have to do is find the derivative of the radius function, which we found at part B, and set it equal to 0. When we're taking the derivative of the radius function, we should note that sine 2 theta equals 2 sine theta cosine theta, and that when we're taking the derivative because we're looking for the max, so we have to set r equal to 0. Once we set the derivative of r equal to 0, we gotta take the derivative of this stuff, so it'd be 0 equals, so the derivative of sine would be cosine, but since we have 2 thetas, we have to multiply by the stuff, so it'd be 5 cosine 2 theta, and then multiply by 2 theta, but we gotta take the derivative of that, and then minus, and then we can set this equal to this, because we got that, so 2 simplify this down, we gotta take the derivative of 2 theta, which would just be 2. So it would be, so we do 2 times 5, which is 10. And then we simplify this down, which is 10 times 2, so it's 20. Alright, so now we can simplify out 10 here. So 2 theta minus. And now for this, we're going to use our trig identity again to go back to sine 2 theta. So now we're just simplifying down further, so we can divide the 10 out to both sides. 0 equals 2 theta minus sine 2 theta. And then we can add the sine to the other side. So we get sine 2 theta equals cosine 2 theta. And then we can divide the cosine 2 theta to the other side. So we get sine 2 theta over cosine 2 theta equals 1.
Okay, so now that we have this equation right here, we know that sine over cosine equals tangent, so we just change this to tangent 2 theta equals 1. So we know from trig identities that if we just had tangent of theta equals 1 and solve for theta, we already know from the unit circle that theta equals pi over 4. But we need to know what theta is to equal, we know what theta is in this equation because there's a 2 over here, so we need to know what multiplies by 2 to get pi over 4. So we know that if we multiply 2 times pi over 8, we're going to get pi over 4. So that's how we find out what theta equals here. So in this equation right here, we now know that theta equals pi over 8. So we know that pi over 8 is a value of theta that gives us the maximum radius. So in order to find the maximum radius, we just plug in this theta value into the original equation. So if we plug this in, we're going to get So we can change this into pi over 4 to make it easier for us to convert and keep this the same. So we know that sine of pi over 4 equals root 2 over 2, so we change this to 5 times root 2 over 2. And then if we don't really know what pi over 8 is, so we just have to put that into our calculator. And once we put that into our calculator and subtract it from this right here, we get that the radius equals 2.07. Okay, so we know that pi over 8 is the value that gives us our max, but we need to double check that this is the real max by putting in a sign chart. But before we plug in numbers, we need to know our practical domain. So we know that angle C is less than 90 degrees because it said that the angles in the right triangle need to add up to 180 degrees. So theta right here, which is half of angle C, so theta equals half of angle C. So that has to be less than 45 degrees or less than pi over 4. So we can make a sign chart, and this is going to be our midpoint because this is what we're trying to test to make sure that it's a maximum. So pi over 8. So we already know that it has to be less than pi over 4, but we also need to know that it has to be greater than 0 because no angle can be less than 0. So this is the point that we need to plug in right here. So for the left side, we can plug in a point anywhere from 0 to pi over 8. In this case, we chose to plug in pi over 16. And we put that into our radius equation to just double check that it's positive, because if it's maximum, we need this side to be positive. So it checked out, this side is actually positive. And for the right side, we need a number greater than pi over 8, but again, it has to be less than pi over 4. So we picked, in this case, pi over 6. And then when we plug that back in, we got that it was negative. So looking at the sign chart, we know that if a function is, actually this is a 0 right here. So we know that if a function goes up and goes flat and then goes back down, we know that this is a maximum. So that then proves that pi over 8 is the value that gives us our maximum.